Okay, so I'm back again. This time we're going to solve a basic nodal analysis problem. I came up with this random circuit just off the top of my head just 30 seconds ago, and we're going to try to solve it and see what we come up with. So it's a simple nodal analysis question. I should give VO. Let's call this VO. So solve for VO using nodal analysis, which means I'm not going to solve it with mesh or superposition. I have to use nodal analysis if I want full marks. What is VO? It's the voltage on this node over here. I have a voltage source, a couple current sources, and a bunch of resistors. And how do I start this kind of problem? Well, let's first see how many nodes we have. So in this circuit, we have one node for the bottom, one node here. That's actually useful. The bottom node we just call ground, so it's 0. We don't solve for it. So I have one node. I have this one VO here. I have this node over here. This one does actually count. So they're not all names. So let's call, let's call this one VA. That one's already named VO, so I'm not going to rename it. I'll call this one VB. I have 3 nodes, therefore I'm going to need 3 equations to solve for all of them. And now, when I solve my equations, what I'm looking for, VO, is just already one of the voltages on the node. So I had to solve whatever matrix I come up with or system equations, and I'll be done. Now, starting off, let's see what we can solve first. VA, that's a big node. I'll have to write an equation for it. VO, it's got a bunch of stuff connected to it. I'll also have to write an equation for it. However, VB is a simple case. So we see how on one side of VB, there's a ground. And on the opposite side of this, there's VB. Well, what we have is essentially, if I have like a virtual, I'll call that VB, and I have 9 volts, and it's connected through the bottom, right, ground. If I draw, or if I write KVL around the loop here, I'll have, start bottom corner, negative VB plus 9 equals 0. VB equals 9 volts. So actually, I can just write VB 9 volts. Makes life quite simple. I don't actually need an equation for that. I just showed you how you can solve for it on this side. Now, let's solve for node VA. Let's write the equation for it. So node VA has a couple current sources and a couple resistors. So what I like to do is, in my equations, it's a Kirchhoff's current law. So all the current going into the node equals all the current coming out of the node. I in equals I out. So I'll write all currents coming in on one side, I'll write all the currents going out on the other side. Actually, I like to put it I out on the left side, I in on the right side. So when I write my equation for node VA, what is going into the node? I would say 3 amps is going into my node, so I'll go 3. Or what's coming out of my node, my bad. 3 amps, as we see, is leaving the node, so it'll be on that side. Now, I just assume that when I look at this node, if I see a resistor, I just assume the current is leaving through that resistor. I don't have to write a polarity or direction anywhere. And if I use this method on all nodes, it will work out. So if I assume the current is leaving through each of these resistors, I can assume that it's I out. So it'll go on the left side. So 3 plus, what is the current leaving through? Let's start with a 4 ohm resistor. Well, if I have a voltage on one side, I have 0 volts on the other, I have a voltage drop of VA minus 0. Now if I want to convert a voltage to current, I'll divide it by the resistance. So it'll be VA minus 0 over 4. So I'll put VA minus 0 over 4. Now, what other resistor can I work with? The 2. So the 2 ohm resistor, I assume it's just leaving the node, the current, just because it's a resistor. So it'll be VA, because I'm just assuming the VA will be the positive side, minus what's on the other side, VO, divided by the resistance, 2. Now the 8 ohm resistor is on top. I could have combined it actually with the 2 ohm, but I'll do it as another part of the equation just to help you practice. So the current, I assume, is leaving from VA, so VA will be the first term, minus what's on the other side of this resistor? VO. What's the resistance value? 8. So that's all the resistors checked off. This will all equal the current going into the node, 3. So now I can simplify my equation, so I'll just factor this stuff. 3's will cancel out, so it'll equal 0. I'll have VA, VB, no VB actually. I'll just have VA and VO. So I'll have VA 1 over 4 plus 1 over 2 plus 1 over 8 plus VO negative 1 over 2 minus 1 over 8. Using my calculator, 1 over 4, I don't feel like doing this in my head. 7 over 8. 7 over 8 VA plus negative 1 over 2 minus 1 over 8, negative 5 over 8. VO equals 0. So that's my solution for equation 1. Now I'll have to write a nodal equation for VO, or that node. So let's do that. So for node VO, I assume if I see resistor, I just assume the current is leaving through the resistor. Now this might seem a bit confusing because when I looked at VA, I assumed the current was going that way. But now when I look at VO, the current's going this way. However, when you see, when I'm going to write my equation, I'll swap the direction, but I'll also swap the order of the nodes in the circuit. So it's a double negative, cancels out. So this method, you don't have to draw arrows on each circuit. Doesn't matter. I can just use a simple method I'll show here. To show you how simple this way is, let's look at my node, VO. I have 4 resistors on it. Now, if I want to go, actually I want to write it maybe over here so you can still see it. So for node VO, what's connected to it? First, 2 ohm resistor. So I'll go something over 2. It's connected to VO, VO minus 0 over 2, plus next resistor. Let's do this one in the middle. VO, just because I'm starting with VO, minus, what's on the other side? VA over 2. Top resistor, it's VO, other side's VA, divided by a resistor. VO minus VA over 8. Lastly, VO minus VB over 4. And there's no current sources going in, equals 0. Nice and simple. I don't have to really worry about directions or anything. Now, I can simplify this because, actually I'll have to simplify it if I want to solve it. So let's simplify this equation. Factor out VA, negative 1 over 8 VA. What VOs do I have? Plus 1 over 2, plus 1 over 2, plus 1 over 8. There's another shortcut you can do to make nodal analysis easier, but I don't think I'll show it just because you want to learn the fundamentals first of what's going on, and then you can use a shortcut. VO, and what is VB? Minus 1 over 4 VB equals 0. But in this equation, VB, we already know to be 9. So we can go minus 1 over 4 times 9 is negative 9 over 4. I can actually just move that over. So what I'll get with, at the end, negative 1 over 8 VA, using my calculator here, 1 over 2 plus 1 over 2 plus 1 over 8 plus 1 over 4 plus 11 over 8 VO. Now that's negative 9 over 4, so I'm going to move it over. I get 9 over 4. So that's my second equation. I have two equations and two variables. I can solve this with substitution, but I'm lazy. I'm going to just put in a matrix and put it in my calculator. So if I do that, I have my matrix. I'll have VA, VO, and whatever is on the other side. Entering the coefficients in, 7 over 8 minus 5 over 8, 0. Minus 1 over 8, 11 over 8, 9 over 4. Solved using calculator. So if I want to solve it using my calculator, once again, this is the calculator I use. It's an older model. It got me through undergrad. I'd say it worked well for me. There's a newer version. I think it's similar, the commands. So if you want to enter, or you want to solve this 2 by 2 matrix, we'll go menu, now go alpha, and then the minus sign here, A, simultaneous equations. 1, how many unknowns do we have? We have 2. So we have 6 spots to enter numbers. I got 6 coefficients. I just plug them in. 7 over 8 minus 5 over 8. I remember to watch my negative signs. 9 over 4. Solving this. So VA is equal to 5 over 4. VO equals 7 over 4. That's actually a surprisingly nice number, given I just came up with the parameters randomly. Well, what is the question asking for? VO. What did I just find? VO. Now I'm going to finalize it, because these are in volts. To make it easy for whoever's marking my paper, I'll write therefore VO is equal to 7 over 4 volts. I should really write that actually in just decimal. Equals 1.75 volts. Put that in a box, and there we go. A simple nodal analysis problem. I'll just run it through by camera in its entirety. I'm going to zoom it out. And there you go. Now, how we can make this more difficult is by adding dependent sources, which would just mean we have another equation we solve for. Or we can add supernodes. So if I had, let's say, a voltage source, no, if I had stuff in the centers, it'd make things difficult. I'm not going to solve supernodes or super meshes right now. I don't think